I never had a very parachute.
Okay, everybody, let's take a look at the word problems we have in front of us here. Quadratic applications. All right, the Royal Gorge Bridge near Canyon City, Colorado is the highest suspension bridge in the world. The bridge is 1,053 feet above the Arkansas River. A rock is dropped from the bridge. The height of the rock can be modeled by the function da 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 da. How long would it take the rock to hit the water? So, well, let's talk about this before we sort of dive in here, pun intended. So you have your function here. Isn't that a parabola? Right? Because it's just a quadratic, right? Since a is negative, what's that parabola going to look like? Yeah, it's going to be something down like a frown, right? So it'll be something down like a frown. Now, t is standing for time. I guess we didn't say that here, but t is time. So at time 0, what would the value be? If time is 0, what's the value of the function when t is 0? Yes, 1,053. So think about what's happening here and think about what's happening. We're on this bridge and we're going to drop a rock off the bridge. So what's happening is that the top of your parabola is probably where that rock is getting released, right? It doesn't say that they throw it up off the bridge. We're just dropping a rock from the bridge. So that makes sense. At time 0, it's the highest it's ever going to be because now it's going to drop. Follow me?
Yeah.
Okay. So t is going to be basically my x-axis, right? My time. So if I want to know how long it will take for the rock to hit the water, what am I really finding on this parabola?
Speed.
It's x-intercept. Now listen, it's going to have 2 x-intercepts, won't it? It'll have one here and it'll have one back here. This is negative time, right? Because mathematically the parabola is going to have 2 x-intercepts. But in terms of this problem, I'm going to just ignore that negative root. It wouldn't make any sense. So let's go ahead, grab our calculators, and we can go ahead and ask it to find us all these values. Where do we go to enter in? Yes, go to y equals, clear out any of the old stuff. Make sure you use the negative button to type in that 16. So negative, it's the one underneath the 3. Negative 16, and we're going to use x instead of t. X squared plus 1053.
You want this?
What does it say?
My best reason.
Sure,
Check this or read it.
it's fine. So just grab yourself a new one. Now, we're going to have an issue when we go ahead and hit graph. So I highly doubt we're going to be able to see all of this. So I can kind of see the x-intercepts, but I'd like to see the whole graph. So I'm going to have to change my window. It doesn't really make sense to keep zooming out because I don't really care about any of this negative stuff. I'm just going to change my window. So if you hit window, I need those y. So if you scroll down to y max, it's only a y max of 10. But I know I'm starting this thing off at 1,053. So I'm going to change my maximum y value to, I don't know, maybe 1,100. And now I'll look at that graph. And that's at least a lot better. I can see more of it. Again, I don't really care about the negative stuff. So if I wanted to get rid of this part, I could. But now I think I have enough to find the things that I need to find. So let's go ahead and find that first x-intercept. The only one that I care about, right? I don't care about the left-hand side one. I did window. So if you go to hit window along the top and you change the maximum y value, we went to 1,100 so we could see the full thing, and then just hit graph. Okay, so see if you can remember how to find this x-intercept right here we're talking about. So I don't really care about the negative x-intercept because it just doesn't make sense in terms of our problem. So where's that? Where am I going, Jake?
You're gonna hit
the second button and you're gonna hit trace.
Yes, it's that Calc menu we need. Remember that? So see, it says Calc above trace. So you want to hit second and then Calc. And from these choices, I'm really looking for a 0. So I'm going to choose choice 2. And then remember all these questions. See that blinky guy? So if you use your left and right arrow keys, you see him moving around. So you got to move him. Oh, we may have to zoom out a little bit more. Let's see if it'll let us do it. Because that intercept is actually hiding. Oh, mine let me do it. By the way, so if you can't see where the blinky guy is going because he's like hiding between the numbers, you can follow him. Like it'll give you his coordinates the whole time. So if you're not quite sure, I know I needed that Y to go a little bit to the right. So I know it's got to dip negative at some point. If you want a little bit more space so it's not hiding between the numbers, just change the window. Go a little bit further down in the negatives if you want. So instead of having the lowest Y value be at -10, set it to, I don't know, -50 or something. So you have a little bit more space and you can see better. But anyway, did you guys get what I got?
What's the time?
I assume this is seconds. Usually it tells you, but I don't know why this one doesn't tell us.
I'm right there.
Yeah, so I would assume that T is in seconds and Y is in feet. Oh yeah, Y is feet. It tells us that part.
We have a specific decimal we can go to, or
Tenths is fine. So this thing is going to hit the water at about 8.1 seconds. If you think about that for a minute, that's kind of a long time for a rock to be falling through, right? So think about how high this bridge must be. It does say it's the highest suspension bridge in the world. So 8 seconds to get all the way down there. That's crazy.
no one want to fall off.
No way. All right, how high is the rock after 1 second? How do you do that? Evan, go
I
ahead.
think I did something wrong.
Oh. Wait a minute. You did, but I'll fix it. Okay, so if I want to know where this thing is at 1 second. Any thoughts? How could you do this? I mean, there's one really kind of easy way to do it. Could you just plug in 1 for T, like without the calculator, right? Because our function's not that typical, so I could literally just pop in a 1 and do whatever 1053 minus 16 is. But say it was something complicated and you wanted to do it on the calculator. Do you know how? You can. There's a couple different ways. You can go to second calc again and then choose value. And then it'll let me type in a value. So if I want 1, there we go. It'll give me that Y coordinate at 1. So if it were something trickier, like, I don't know, like 2/3 of a second, you don't feel like plugging it in directly, or I don't know, something weirder, that might be helpful. So you can go to second calc and then the value. There is a way to do it in the table. The table is nice when you need a whole bunch of values, but the table will only give you whole numbers unless you change the increments. So that one can be a little, it's useful for some things, but not others. So anyway, after 1 second, we are at 1,037 feet. How long would it take for the rock to reach a height of 500 feet? Ooh. I know you know how to do it, like by hand. I assume you know how to do it by hand. Jake?
For 500 for wire for SMS space and solve for T.
Sure. So you could certainly do that. You could take 500, plug it into the function and do it out by hand. There is a way to do it on the calculator. And there might be multiple ways, but here's kind of a neat trick that you could do is I could just graph the line y equals 500 and see where the line intersects with my parabola. Isn't that neat? Let me show you. So if I go back to y equals, and then just in my second, so if I go down to y2, and I just graph y equals 500, and then look at my graph. See how it draws a line right through my parabola? So when y is equal to 500, I know it's going to happen right here. So all I need is that x value. Now, I mean, I can kind of guesstimate, but I'll have the calculator tell me exactly. Take a guess what menu I'm going to go to. Yeah, I go to second calc, and now I'm going to choose choice 5 because now I have two things that I want to find the intersection between them. So choice 5. It's going to ask you, hey, is this your first curve? So if you see the blinky guy, he's just saying, is this the first curve you want? Yep. Is this your second one? Yep. Yes, it really doesn't matter. And look, it'll tell me exactly where those two intersect. So now I know without doing a ton of work by hand. I mean, not that this one was that bad, but boom, there it is. So that means after 5.88 seconds, it looks like, my rock is going to be at 500 feet. Isn't that something? I knew you'd like that. Look at all these cool tips and tricks. So what was our answer? 5.88-ish. Is that so bad? Questions like that? No. And what's nice is you can do them by hand, but having the access to the graphing calculator just makes it that much faster. All right, let's see if we can work our way through the second one. A billboard is 10 feet longer than it is high. The billboard has 336 square feet of advertising space. What are the measurements of the billboard? Well, let me ask you this question. Do you know how high the billboard is? Yeah, let's call it X. So if the height is X, what's the length? X plus 10. It's telling you that it has 336 square feet of advertising space. What is that really? What is 336 really representing? The area of this rectangle, exactly. And to find the area of a rectangle, I just multiply length times width. So what they're telling me is that X times X plus 10 is going to equal 336. All right, cool. So we can turn this into a quadratic real quick. If I just distribute, you actually don't even have to distribute, but I'm going to. Why not? And now I'll just bring that 336 over. Okay, so now I have an equation that I can go ahead and I can put that in my calculator if you want. If you want to just do it by hand, you could too. Again, I'm probably going to have to adjust my window. If you hit graph, let's see what we see. Oh, I don't even see mine. Oops. So let's see, this thing is, I'm going to put in, well, at 0, you're at negative 336. So why don't I change my y min instead of that being negative 10? I'm just going to change it to negative 500. Let's see what we get at with that. Okay, now I can at least see part of it. What am I really looking for? I'm going to zoom out a bit more. zoom out, choice 3, and then I hit enter. Aha, there we go. Now I can see more of it. What am I looking for? What on this parabola is going to give me the answer to this question? Jake?
Your roots.
Yeah, my roots. Again, I have one negative root, which won't make sense in terms of this problem. Because think about I can't have a negative side length of a rectangle. So I'm actually going to ignore this root over here, and I'm just going to focus on this one. So if I just find that root, I'll have my answer. So remember, you want to be a little bit to the left of the intersection, or the intercept. Go a little bit to the right. I got 14. Could you have done it by hand? Sure. Is it faster to do it with a, if it's a nice number, yeah, it's not that hard to do it by hand. But if it was like a nasty number, I would definitely want to calculate it. How'd we do? Easy enough? What was that?
I don't know what's,
Do you have your whole parabola?
yes, is it like a very sharp key?
It's your bucket. Let me look at you.
That's a very like laser.
So what I did was I changed my minimum Y right here. So I knew that this thing was going way negative, and then I saw that it still wasn't far enough. So then I had zoom out, and then it zoomed out, and then I could see everything. But
Well, I got personal zoom out too, but. That's what I changed.
my max set it to 40. Yes, and now you're just kind of like that. Everybody else okay? All right. So that's pretty much all that I have for these. So my thought is tomorrow we'll practice a few more word problems. Let me stop this share.